Hello everybody. Today we're going to take notes on significant figures, which is just many times shortened to sig figs. This is a very, very important concept, especially in physics and chemistry, and it will become even more important as you take AP classes in high school. So, here we go. Significant figures are important because for measured numbers, sig figs relate the certainty of the measurement. A few days ago, I taught everyone how to properly use a ruler, and I showed that the ruler now tells you how many digits to write down. Well, if we had used a better ruler, a more expensive ruler, a more expensive piece of equipment, then we can pay for more significant figures. There are more numbers that we can know for certain. So as the sig figs increase, the more certain we are about that measurement. Of course, like I just said, what will determine that is how much money are we willing to pay to get that measurement. How badly do we need to know those digits? So for example, if we measured something that was 8 centimeters, nothing more, nothing less, just 8, that has one significant figure. Because if we actually knew what these digits right here were, if we knew that these digits were zeros, then we would write them down. But we don't know them because we didn't measure them. In my video a few days ago, this would be the ruler that only has a mark every 10 centimeters. So we know the 10 and we guess the 1. So we're just guessing that this is about 8, but we don't know any other measurements because we didn't use a good ruler to get them, or we just didn't take a lot of time, or the person who did it didn't know what they were doing. The only number we know is 8, and even that is kind of an estimate. But if we get this measurement, we are using an amazing ruler, first of all, because we now know, this is a ruler that probably goes to the 100th of a centimeter, and we even can estimate the 1,000th of a centimeter. Well, this is an amazing ruler, and it also goes to 4 significant figures. In this, we don't know a single number after the 8. They could be anything. But these, we paid money. We paid a lot of money, probably, to get these measurements. I have a friend that works as a tool and die maker. He makes pieces for like machines for a living. And if I ordered a piece of aluminum from him that was an 8 centimeter cube, he could probably make that for $1 or $2. But if I asked him to make me a cube that was 8.000 centimeters on each side, I need that cube to be perfect, he's probably going to charge a couple of $100 for that same piece of aluminum, because I am asking him to make sure that these numbers are zeros, not up here where I just don't know and I don't care. So, moving on. In order to count significant figures, there are 5 rules. I need you to get all these in your notes, and then the first worksheet is all about counting significant figures. Sig fig rule number 1. All non-zero digits are significant. Meaning, if it's not a 0, then it is significant. 1, 2, 3, 4, 5, 6, 7, 8, 9, they are all significant, and we count them in the measurement. Another key point back in the previous slide, this only matters about measurements. If I just gave you a number, I said 2, how many sig figs does that have? Doesn't have any, because 2 is not a measurement. But if I say 2 centimeters, now we have significant figures, because now we're talking about a measurement. So if it's not a 0, it's significant. For example, let you think, that has 3 sig figs. And this number has 2. The 2 and the 5 are significant. The 4, 5, and 7 are significant. What about that 0? Well, funny thing. The other 4 rules of sig figs are all about zeros. Zeros are what make it complicated if you want to think it's complicated. Number 2. Number 2, zeros between non-zero digits are significant. So if you have zeros between our non-zeros, 1 through 9, then they also are significant. The examples here, 1,005 kilograms. How many sig figs does that have? 4. Because the zeros between the 1 and the 5 are also significant. 1.03, the answer, 3. The 1 and 3 are significant because of Rule 1. The 0 is significant because of Rule 2. Rule number 3. Zeros to the left of the first non-zero digit in a number are not significant. They merely indicate the position of the decimal point. For example, this number has 1 significant figure. The zeros before the 2 are not significant. They simply tell you where the decimal point is. Another example of this would be if I were to write a number like, hold on, let's see if I can write a number as you think about the next one. If I were to write this, and I said 6, most of you would probably look at me funny because why did I write all those zeros? Exactly. I don't need them. Here you need them because without that 0, this is no longer 2/100ths of a gram, it's 2/10ths of a gram. It's not that those zeros aren't needed, it's not that they are significant in the measurement. Remember, this is all about measurements. So, you thought about the second problem. It has 2 sig figs. All the zeros before the 2 are not significant. Rule 4. When a number ends in zeros that are to the right of the decimal point, they are significant. So let's say you have a number that ends in zeros. The zeros are to the right of the decimal point, then they are significant. They have to be counted. Now we got a couple of things going on in this problem. Let you think about it. And the number of sig figs, this has 3. From rule number 1, the 2 is significant. We don't have any between, so rule 2 doesn't matter. Rule 3, the 2's before the 2 are not, but this number ends in zeros, so the zeros after the 2 are. So the 2, the 0, and the 0 are significant. While I'm thinking about it, on this problem, when you start counting these, one thing you might want to do is go through all the rules and say, okay, that one is because of Rule 1, those are not because of Rule 3, those are because of Rule 4. Well, now you know that there are 3 significant figures. Next, 3.0 centimeters. And how many sig figs does that have? The answer is 2. And then 3 more slides, but it's because of Rule 5. When a number ends in zeros that are to the left of the decimal point, here's the fun thing, the zeros are not necessarily significant. They might be, they may not be, we can't tell. But when we start doing calculations with sig figs, we've got to have a certain number of sig figs in our answer, so we've got to start writing them with a certain number of sig figs. For example, if we're counting sig figs, this number ends in zeros, or a 0. The 0 is before the decimal point to the left of it, so it may or may not be significant. So how many sig figs does it have? Well, we know it's 2 because of the 1 and the 3. We're not sure about that 0. So we know it's 2, but if we count the 0, it's 3. The answer is 2 or 3. We can't tell. Is this person really sure about the 1 and the 3? Or are they really sure about the 1, the 3, and the 0? What did they mean when they wrote this number down, this measurement down? The next one, 10,300 meters. How many sig figs does that have? Well, the 1 and the 3, the 0 between, but what about those zeros at the end? Maybe, maybe not. The answer, 3, 4, or 5. We don't really know. Did they do a good job up to the 100? Or did they do a good job up to the 10? Or did they do a good job all the way to the 1? We don't know what they meant. Well, we've got to know what they mean. So when we start doing calculations, we've got to be able to write these numbers with the correct number of sig figs. Here's how we do it. If we want to show 130 with 2 significant figures, we can first write it in scientific notation. This number here must be between 1 and 10. If you say 10 point something, you could easily turn it into 1 point something and simply make the exponent behind the 10 a different number. And as a quick review of scientific notation, please note that what have we done? That 2 means we move the decimal point 2 to the right. So that's how we get 130. Another way to think about it, what's 10 squared? It's 100. 1.3 times 100 is 130. But because of that part of this in scientific notation, it has 2 significant figures. Another way to go about it, underline the 3. That way you're saying the 1 and the 3 are significant, the 0 is not. And now you're saying this has 2 sig figs. Now let's show that same number with 3 sig figs. Notice all I've done, this is still between 1 and 10, but we've now added a 0. That 0 is significant because of rule number 4, but now it has 3 digits. That makes it 3 sig figs. It's still 130, but now it's 130 with 3 sig figs. Another way we could show this with 3, underline the 0. Just like in this one, we underline the 3, now we can underline the 0. And the easiest, and probably the one where you say, why didn't you just tell us that to begin with? If you want to show everything is significant, put a decimal point at the end. If you put a decimal point at the end of a measurement, you're saying everything is significant. That what you wrote down, you know the 1, you know the 3, you know the 0. Now let's quickly go through the other one that we just looked at, 10,300. How do we make those either 3, 4, or 5 sig figs? That's how we would do 3 sig figs as scientific notation, or we can underline the 3. 4 sig figs, there it is in scientific notation. Underline that 0, so everything in front of it is significant. Or if we want to show it with 5 sig figs, add another 0 there at the end because of rule 4, and it's still between 1 and 10. underline that last 0, or put a decimal point at the end. These are the rules for counting sig figs, and sig figs are all about measurements. Tomorrow we will be taking notes and doing another worksheet where we actually do calculations with these. Please work on your worksheet if you can, but I will give you time in class to work on it as well. Thank you very much.